Okay, so the second part of this lecture is about, we dive straight into a fairly complicated system. It's called the Git version control system. And I have to warn you, it might be a little bit, it's a very complex system. It's used by the largest open source projects out there. So it might be a little bit overwhelming first. But I hope I give you a little bit, I want to give you kind of an easy introduction to it. But I also want you to teach you kind of the core concepts of these version control systems. Because if you understand these, then it will be much easier for you to understand what's going on if there's something goes wrong. Right? So I hope this is helpful. Can I just ask how many of you have never seen Git? A few. So almost everyone has used Git a little bit? Yeah? Okay, good. So, okay, I mean, some of this might be already known, but it doesn't matter. So version controls, so Git is a version control system. So first we need to talk about what is a version control system. It's a software system to manage changes in documents. So these documents, they could be text files, but they could also be computer programs. In many cases, they are computer programs. They could be large websites and other collection informations. So I use version control system for my software, but I also use it, for instance, for writing papers. All my master students are using it for their master's project, and all my PhD students are using it for their PhD's thesis. So version control systems is not restricted to computer programs, but the point is that you can track how the document changes over time. This is the main idea of these version control systems. So typically you have, let's see, there's some text on there. But so typically what happens is that you have one main server that stores all the documents that you're trying to track. And this server has kind of a version database with all the different versions of that document. Right? So version 1, 2, and 3. And so typically that server sits somewhere on the cloud. So for instance, in our case, it will be github.uio.no. And then we create local copies on our computers. Right? So maybe we're working with two computers, computer A here. And our local laptop also has a copy of this version database, so it has the same versions. But it also allows us to introduce new changes to the document. Right? So we can edit these documents here, and then once we can make them part of the official version database, and then we can sync it with the main server. And of course, there might be a second computer that does the same thing, and so we need to kind of sync in all cases. And when two people are working on the same documents, it's not too uncommon that there are conflicts. Right? So and there are two types of conflicts. There's conflicts that can be automatically be resolved. So imagine one person is working on document A and then the text file A, and the other person is working on text file B. Right? Then they kind of create new versions, and you're trying to sync them, and that's kind of very easy, right? Because the changes are in completely different documents. So in these cases, these conflicts can be automatically synchronized, but there might be other conflicts when programmers edit the same line in the same document, right, independently, and then you're trying to sync it. Then there's no easy way to do this automatically, and then there might actually be manual intervention be necessary. So that was kind of the main idea. What are the use cases of version control systems? Well, I would say there's kind of three main ones. The first one is organization. So once you have your documents in a version control system, you can get older versions of your files. You can look at the history of changes, for instance. You can also diverge from your main, let's say you're doing software development project and you want to try out some kind of testing implementation, you kind of can diverge into the testing branch and easily go back in case it didn't work out as you planned. Then there's collaboration. So if you're working in a team, you can use these version control systems to share your code between people and work simultaneously in the same code base. And you can track the changes on individual people and quickly undo them if necessary. And last but not least, it's very useful because it's an automatic backup, right? So because you have these different copies on different computers, but also in the cloud, even if one hard drive dies, you can just get a copy of one of the other computers. So there's many version control systems out there. We are going to use Git. It's one of the most used version control systems. It's developed by the Linux kernel developer, inventor, Linus Torvalds. I guess part of the reason why it's so popular is because it's very fast. It's decentralized, so you don't necessarily need to have a central server that stores it. It can be completely just local machines, and it's open source. There's a very good ecosystem for storing Git repositories online. So GitHub I already mentioned. I often also use Bitbucket, which is just another web page. Installation is fairly easy. If you're in an Ubuntu machine, you just type in sudo apt-get install git. And then there's a very good book that I recommend. It's free to download here. And part of the lectures is actually inspired by that book. So let's start. Let's create our first Git repository. So a Git repository is simply a folder in which you want to track your changes in. So in our simple example, let's say we have a project in this folder, my source. And then in order to make this folder, so in here we want to develop our project. And in order to track changes, we need to create a Git repository. And the way you do that is you type in git init dot. Dot refers simply to the directory in which I'm in, which is the my source. So I need to explain you how this works. So these are executable slides. So I can actually run this code. And what you see below here, this is the output that you get. So essentially, this is the same as if I had typed it into a terminal. And if you want to follow the slides, you can do the same steps in your own terminal. So what it tells you is initialize empty Git repository in this folder. And if you, so if I, let's see. So here, I can now jump in this terminal, right? And you can see that this my source directory, I can look into it. And if I do an ls to list all the files in this directory, you see nothing, it's still empty. There were no files before, there's still no files. But if I do an ls -a to also show hidden files in the directory, you see that there's this .git folder now. And that tells you that you're working now, or that this folder is now a Git repository. So essentially what this git init command does is it creates this .git folder. Right? And in that folder, Git stores all the history information of that folder. So by default, Git does not track any files in that folder. So you need to explicitly tell it which files to track. The way you do that is with the command git add and then the file that you want to have tracked. So what I do is here's the first line, I simply I print a string. And so we'll talk about this in the next lecture. But essentially, I create a file with some content here. And then I call it myfile.py. And then I tell Git, please track that file. So we can run it. There's no output. But trust me, Git now tracks it. So now we've done our first implementation of myfile.py. Git is tracking it, but we haven't done any snapshots yet. So we haven't stored any version of that file yet. The way you create snapshots in Git is with git commit. And then -m is a parameter where you tell it a message describing what has changed since my last commit. Since I haven't a last commit, I just say initial version of myfile.py. Okay? So with this command, we create a first snapshot of my repository. So I can run it, and you can see it tells you, it gives you some information. It tells you, again, the message that I've typed in. And it also tells you what has changed. So there's one file that has been changed. Currently, we're only tracking one file, so that's not so surprising. And there was one insertion. This simply tells you how many lines have been affected, right? Since my file only consists of one line, again, that's not so surprising. OK, so that's it. So now we've created we've created a Git repository. We added it to tell Git that it should be tracked. And then we created a first version of that. So now things become a bit more complicated. Once you've committed something, you can now, the files can be in different states, in different Git states. So the first one you already know. A file can either be tracked or untracked, right? If a file is untracked, Git will never touch it. It'll just be there. But if it's tracked, then it can be in 3 different states. It can either be unmodified. This simply means that there's been no changes since the last commit. So our myfile.py file, that's currently in the state unmodified, because I've just committed and I haven't made any changes since then. Then it can be modified, which means I've done some editing in the last commit. Or it can be staged, which means that these changes are now ready to commit. And so this is a bit overwhelming first, but it's important to get this right, because sometimes it's a bit confusing in a certain situation. Yeah, you'll see in a second. But anyways, this is kind of how it works, right? When you have an untracked file and you type git add, then the type or the state of that file is a staged one. And then when you commit it, it becomes unmodified, because now there's been no changes since the last commit. Then you edit the file, then it changes the state to be a modified file, and then you call it git add, and then you make it, then it becomes a staged file, and then you commit it again, right? And so that's the common workflow, right? So you first edit, then you call git add, then becomes staged, and then you call git commit. And then you edit again, git add, commit, and so on. It's just about the... yes?
If the file is modified since the last commit,
yeah.
we need to add it again?
Yes, and you'll see that in a second. We'll do exactly that now. So so the first important thing that you need to know, that I want to tell you, is there's this command git status, where you can ask about the different states of the files in your repository. And so, maybe to begin with, let's just do a quick git status before we do any changes. So if I just call git status, it just sends, I'm on branch master, okay? Nothing to commit, right? Working tree clean. So there's been no files that are that have been changed. But now in these 2 lines, I'm going to edit the myfile.py file, and I also create a new file called readme.md. So let's do that. And now let's call git status, and let's see what happens. So now we have the myfile.py file that has been modified, but it has not been staged. Right? It's a modified file that has not been, I haven't called git add yet. So it's not staged for commit yet. And then I have this untracked file readme.md, because so Git doesn't track that file at all yet. So that's the status now. And so if you're in, so it says myfile.py has been modified. If you want to know the if you want to see line by line changes that have been performed, you can call this. You can run this command git diff. Git diff looks at all the modified changes and tells you what has been changed. And so this green plus tells you there's been a new line added. So this was the line that I've added at the very top. Does it make sense? So now, as you exactly pointed out, before we, in order to now include these changes in a new commit, we have to add them again. So we write git add, and I want to now have both the README file and the my file. And by calling this command, I move both files from modified versus an untracked. I make them both staged, right? So I can do that. Let's run it. And then if I run git status again, I now get changes to be committed, these two files, right? And I'm happy with this, so I can run the git commit file again. And so now you can see there's been 2 files changed and 2 insertions. Yeah?
If we just add README file and then commit it and commit my file separately.
Absolutely. I could have made 2 commits instead of 1.
So there's like no need of adding my file anymore.
If I hadn't done this and did a git commit, then afterwards my file would still be modified because I hadn't committed. So so this will be your first exercise will be to play around with this. So hopefully you get some practical experience with Git. But so why are we doing all this? The reason is that because we make a history of our documents. Well, the point is that we can look at past, or at least that will allow us to look at past versions of our documents. So for every commit that we create, you need to imagine that Git creates a snapshot of all the tracked files in your repository. And it marks this snapshot with a unique identifier. So essentially what you end up with is that you end up with a kind of a sequence of identifiers that represent the different snapshots. So this was our first commit, and actually we only had 2 commits. But in this plot here, you see a history with 3 commits. And you can actually ask for this history with the command git log. And I just use one line here to shorten it a little bit. But remember, we only had 2 commits. The first one got this identifier here, and this is the commit message that I gave it. And then the second one is here, this identifier with the second commit message. But so the question is, now we have many, if we have many versions and we can move around, we can go into past versions in the history. The question becomes, how do we know at which version we are currently at? And the answer to that is that there is a so-called a head pointer. And the head pointer points always to the version that is that we're currently looking at it in our directory. And so by default, when we make a new commit, the head pointer simply moved forward. So the head pointer always shows to the latest commit in your repository. So you can see that if I call this git log again, you can see that the head pointer now shows to the latest commit, where we've added the README file and fixed the my file. Okay. There's some, just skip this. So now it should be fairly obvious what to do if you want to move back to an older version. All we need to do is that we need to move this head pointer to the commit of which, or to this commit identifier to which we're interested in. And by moving this head pointer back, Git will automatically change all the tracked files in that repository and revert it back to that old version. Okay? And so the command for moving around the head pointer is called git checkout. And then git checkout and then the identifier that you're interested in. So let's do that. I just call git log again to find out which identifier I'm interested in. And so we've only got 2 commits, right? And the second one we already add. So of course I'm going to pick the first commit. Okay. So now I've moved the head pointer to the first commit. So in principle, the repository should now be at the same stage as at the very beginning. We get some output here, but that's okay. So now let's do another git log. And so now you can see, so here before the head pointed to the second version, but now after this git checkout, the head moved down to the initial version. Okay. I mean, that's not so interesting yet, but the interesting part now happens if I do a simple ls to list the directories in my directory. And you can see the README file that we had created before has now disappeared because we reverted back. We went back to the original version, and there was no README file at the original version. Also, if I just show you the content of my file.py, it's only got 1 print statement, while our second version had 2. Okay, so you can quickly see. You can quickly go back to that old version. So now the question is, what if you now want to move back to the original version? Yeah?
If you modify the one that you went back to, and then stage or commit on that one, will that one become the head, or what happens to the head if you do any changes on this version?
Yeah. Then you're creating a so-called, you're diverging. You don't have a linear history anymore, right? But you're creating kind of a new path. And these new paths are called branches, but they're typically called branches, and I'll talk about them in a second. So in principle, what you could do is you could go back, create a new commit, and make it a branch, and then you would kind of have 2 diverging history flows. You could do that. But at the moment, I just want to keep things simple for now. So we went past in the history, and now let's say we've inspected, we looked at the code that we figured out what we wanted, and now we want to just go back to the latest version. And of course, we now use the same command, git checkout, and I could either now copy and paste the latest identifier, or I can also just use this shortcut master. Here, and then after I've done that, you'll see that I have both files back again. So I'm now at the latest version again. Does it make sense? Any questions? Yeah?
So you create a branch, the head moves automatically to this branch.
Okay, can we just postpone questions about branch in about 15 minutes? Because I will talk about branches now. Yeah, thanks. Any non-branch related questions? No? Good. Okay, I haven't talked about this, but it's fairly easy. So if you, of course, I talked about adding files. You can also remove files. It's called git rm myfile.py. And then if you do a git commit, then that file will disappear. So keep in mind that it's only removed in future versions. You can always get that file back by going back into history to the point where that file existed, right? So removing files in a Git repository isn't really that dangerous. And you can also move files or rename files by call git move. Old name, new name. So git cheat sheet, part number 1. Git init creates a new local repository. Git status shows the status of all the committed or uncommitted files. Git commit commits the files. Git rm and git move. Remote repositories. So remote repositories are important because at the moment, our repository only existed locally in our machine. But as I mentioned at the beginning, is that the idea is that we have our local version, but we have a copy in the cloud, right? That we sync against. And so to demonstrate how this works, I created a simple repository online on GitHub. So this is what it looks like once it's created. And so I'm sure you're familiar with this. This is kind of the repository name. And then currently, I already have a readme.md file. So here it lists kind of the contents of the repository. It's just one file for now. So now the trick is that what I do is I clone this repository onto my local machine. And then I can make changes to that repository. And then I push these changes again up to the cloud. So in order to clone that, I need to get this URL here. And oops. Wait, sorry. So this URL you need to copy and paste. And then you type in git clone and then the URL of the repository that you want to clone. And then let's do that. So it clones it. It takes a little bit of time, and then it. So of course here you need an internet connection because it downloads the contents of not only the contents but also the entire history of that repository. And then the repository will be called mytest in this case. So now what we can do is we can. Now we have a local copy of that repository, so we can operate it as we already know. So I can. So what I'm doing here is I create a new file called main.py. I add it, then I commit it, and then the last. So this is common knowledge now. But the last part, git push origin master, pushes the changes, pushes the commit that I've just made to the remote repository. So it's this git push command that is now the new part. And so you can see that there's, again, something going on. It's kind of compressing it and then uploading it. But the point is now, after this, if I go back to the website and I refresh this page, you can now see that there's my main.py file. And you can also click here on the commits. You can see that there's now 2 commits with 1 commit that I just added 27 seconds ago. So the same thing also happens when it might be, so if you're the only one working on that repository, then it's enough to just push always. But what can happen is if you have someone else working on the same repository, it could be that the other person is pushed in the meantime. And then if you're trying to push, then there might be conflicting changes. So then you will get an error message, and Git will tell you first need to pull the latest version onto your local machine, resolve any potential conflicts, and then push. Right? And so essentially, if you're working in teams, what you sometimes need to do is you need to upload the latest changes from the remote repository to your local one. And that's the command git pull origin master. And I won't go into that because that's going to be part of your first assignment. So git cheat sheet part number 2. I've shown you how to use the git clone command to download online repositories, git pull, and to pull changes from the online repository, and then git push to push them up again. Great. Questions? Yeah?
Why do you use origin mastering?
Right. So again, that's branch related. So, but I explain anyway. So the origin means this is the place where you want to push to, and origin is the default name. If you only have one remote place that you can push to, it uses the name origin by default. So this is where you push to, and this is the branch that you want to push to. And by default, we are working on the master branch. And now we're going back to branches, which I'm going to explain now. So sometimes, this origin is always the same, but in practice, sometimes you might want to change this branch name here with another branch name. Yeah, but the perfect introduction to the next topic. So yeah, we'll see how far we get. But so far, the entire history in Git was linear, right? We added files, then we committed them, we changed files, we added them, we committed them, and so on. And then we could go back and forth. But really, the power of Git is in cases where this history is not linear, but it starts diverging. And so why is this so important? So imagine you're responsible for kind of a big website. And a common thing when you work on this programming channel, but let's take a website. A common kind of working setup is that you have the current version of your website, and then of course you do some development, right? So you want to implement some additional features. But so now, another common problem that happens is that there's some issues with the current version. So you need to add some kind of hot fixes for your current version. And so what you typically do then in Git is that you have your current version. Then you create a so-called branch. It's a separate development flow where you implement additional features. And then in case there are any problems with the original version, you go back to your, let's call it production version. You implement some hotfixes, right? So now you've got a diverging branch. You implement the hotfixes, then you put them online so that your website is up and running. And then you can continue working on your new features. And by the time your new feature works as expected, you can move these changes into the version with the hotfixes. Right? So the point was that you end up with a development history that is not linear, but it starts diverging. And then at the end, it hopefully converges again to one with one code pipeline. So in simple words, branches are lightweight copies of the main repository that you can play with. And so a common scenario is that you use it for testing of new code without having to touch the main repository. So, and again, conceptually, I think the easiest way to understand it is if you understand how it works behind the scenes. So remember, head is a pointer to the latest commit that we have. But I wasn't quite honest when I said that, because really, we also have these pointers that are called branches. And again, a branch is just a pointer that has a name and that points to a specific commit. So really what's going on is that head points to master and to the master branch, and this pointer master points to the commit that is represented. And so master is, when you create a Git repository, there's always going to be a master branch. That's the default branch that you're working on. But now let's say that you're working on a software project and you want to implement some testing features. And so because they might break your code, you don't want to do this in the main branch, in the master branch, but you want to do it in a new branch, in the testing branch. So then what you do is we use this command git branch testing to create a new branch. Let's do that. And what is happening behind the scene is simply that we've created a new pointer, a new red pointer that is now called testing, that also points to the same commit. Okay? That's all. We haven't changed head, we've only created a new pointer. And we can see that if we call this git log again, that now this is our history, right? We have the head pointer, head points to master, but there's also this branch. From now on, I won't call it pointer anymore, I will just call it branches. Head points to the master branch, and then we have another testing branch. That is also is on that commit currently. Okay, so now of course we don't want to, so right now in this scenario, if we were to do a commit, then because we count the head points to the master, if we were to commit now and make changes, then we would make changes to the master branch. That we don't want to do. So now what we need to do is we need to move the head pointer to the testing branch. So the way you do that is, we've already known this command, it's called git checkout. Git checkout was the command to move the head pointer, and we now use the name of the branch to move it. So git checkout testing simply moves the head pointer now to the testing branch. And so again, we can look at this. Oh, I haven't executed it, so let's do that. Okay, so now our history git log tells us that head now points to testing, and there's still the master branch here as well. So the next step is that now we can start experimenting. So we implement our new feature. Our new feature is a very exciting hello world text file, testing.txt. So we create a testing.txt file, add it to the repository, and commit it. And so, because now we are on the testing branch, the commit testing will be, so okay, the new commit will be created, so we get this new identifier, and the testing branch is being moved forward to that new commit. So both testing and head now point to the new commit, but the master branch still stays at that old one. Clear? Let's do it. Execute it, commit it, and then we look at the log. And that reflects exactly what we said, right? So master is still on the second commit, while both head and testing have moved forward. Okay, so now of course what we can do is I mean, we continue this, but now let's move back to master. Let's now assume the case that someone has reported a bug, and we quickly need to do a hotfix on the production branch, which is in our case the master. So what we need to do is we need to move the head again to master. So we call git checkout master. Let's do that. And so now if I do an ls to list the files, you can see that the testing.txt file is not there anymore, right? If I went back to testing here, git checkout testing, so now I'm in the testing branch, you can see I have these three files, testing.txt. But if I go back to the master, I only have myfile.readme.imd. So just confirming that really we have now two different development branches. And so now comes the exciting part, right? So now what we're doing is we're creating a hotfix on the master branch. So we create another file, we add it, and we commit it. And so now the history is completely diverged. The first three commits were the same. Then we created some testing features. Then we went back to master and created a hotfix. So now we have two histories that have diverged. Then you can look at this with git log. Git log reflects it also nicely visually. So we have in our case, it's just two commits that are common. And then we have one diverging one that is the testing. And then we have another diverging one that is the update of the master or hotfix. Does it make sense? So then the last step is, let's assume that we are now happy. So this master is fixed, everything works as expected, but also our testing feature turned out to be a correct implementation, so we're happy with it. So now we would like to move these changes here into the master branch. Okay? So now what we need to do, and that step is called merging. So we have separate development flows, and now we merge the code again to have the changes of both. So that's called merging branches. The command is, the way you need to do that is, you first need to go to the branch in which you want to merge the changes into. So we want to be on master branch and merge the changes from the testing branch. So what we do is, if I just call git branch, it tells me which branches I have and which I am on. So I'm already on the master branch. So that's the one I want to be on. And then I do the merging command. The command is here, git merge testing. So I want to merge the changes from testing into the branch that I'm currently in. And so I have to do that in the command line. So I just copy this. And you see in a second why. Because, so git merged, so just git branch. Okay. I'm on master. And I do git merge testing. Okay. Oops. And then an editor opens, and it asks me, so that's why I had to change the command line. An editor opens, and it asks me to add a message on what is this, what has happened in this merge. So here I'm going to write include the testing features, include new testing features, right? I mean, these messages should be descriptive messages that you can, when you read the history, that you understand what happened. Okay, then I save this, and the merge has finished successfully, so there was no error message. So now I can do another git log, and we can look at the history again. So you can see that there's a new commit that was added, where both head and master are now pointing to. And you can see that that commit includes the history of both branches. So now we've got a unified history again. And now if you look at the files that are in this latest version, so if I do an ls here, you see that we have our my file and readme, but we have both the master.txt, remember that was our hotfix, and the testing.txt, remember that was our testing feature that we've implemented. So git cheat sheet part 3. I've taught you how to use git branch to create new branches. Git checkout to move the head pointer either to a different branch, but it could also be an identifier of a past commit. And then git merge to include the changes of a different branch into the current branch. Okay, that was it for today. Do we have any final questions? Yeah?
What happens if the testing branch edits some file in the master branch?
Yeah, so are you saying if both the master branch and the testing file have changes in the same file? So Git will try to resolve. Git is quite clever. So it actually knows that you're talking about, if it's not a Python file, it knows that you're talking about a Python file. And if it's kind of different functions, if the changes are in different functions, it can actually merge these changes automatically. But if both branches have been made changes on the same file in the same lines of code, then it will say merging process failed. Please look at the files manually and resolve it. And that will be actually part of the first assignment.
We have
Yeah, yeah. So there will be, you will be kind of in a hanging state until you fixed it, and once you fixed it, you essentially Git follows you through that. But there's kind of a Git commit at the end, and only then will be the final commit that includes merges the history. Okay, see you next week.
This lecture right here like overlaps with another course, so I was just wondering if so the schedule is going to stay the same on today.
Yeah, but all the lectures are published online, right? So I'm planning on
Recording and just